Now, let's get this unit off to a really good start. Here we go. By the way, Sister Marianne is the only teacher at the keyboard who's been here longer than me. And the two teachers who came with me, left, and came back are Mr. Miller Mike and Mr. Spurgeon. All right, so here we go.
Sorry, I'm trying to get my notes out.
Here are our functions, and we are to determine if they are polynomials or not. Now, does anybody have a gut feeling about any of those if they are polynomial functions? Do you know what polynomials look like? And which of those, if any, don't fit the pattern? You have a wild guess? The second one, absolutely not. This is not a polynomial. And it is not a polynomial because you cannot have a variable under a radical. This is the same as a 4/5 exponent. This means the 5th root of x to the 4th means x to the 4/5. You cannot have fractional exponents, okay? If you are a polynomial, you cannot have fractional exponents, all right? You're exactly right. This one is not a polynomial because if you are a polynomial, you cannot have negative exponents. This is the same as 1 over x to the 15th. Well, actually, it's 3 over x to the 15th. But you cannot have a variable in the denominator, and you cannot have a variable under a radical. Those manifest as negative exponents and fractional exponents. Can't have them if you're going to be a polynomial. Okay? Guess what? These are all guesses. These are all polynomial functions. Take a look at their exponents, guys. Are their exponents positive? Yep. Are they fractional exponents? I'm talking about the exponents fractions. Nope. So we're all good. Those are polynomial functions. Now, the first part of this chapter, and we will split it like the last one and test over the first part and then the second part. The whole first part is about polynomial functions. When you graph any of these things right here, when you graph these from negative infinity to positive infinity, they are nice, smooth curves. You never break it, you never pick your pencil up. They are nice, smooth curves. This one is just a line. You recognize that, right? This one is a parabola. One piece, nice smooth curve. And this one is one of those squiggly lines, but again, it's unbroken. It's a nice smooth curve. Those are polynomials. All right, so the easiest polynomial is the one whose degree is 1. Remember, when we have something written in polynomial form, let's just do this. This is the degree of the polynomial. You remember that? So that's a 3rd degree polynomial. This is not in your notes. I'm just giving you some vocabulary you may have forgotten. That's a 3rd degree polynomial. This guy right here is called the leading coefficient. You remember that? And this guy back here is called the constant. So the constant term is the one that doesn't have a variable. So no matter what you let x be, this is still going to be -3. It's constant, right? Okay. So the simplest polynomial would be degree 1. And that's linear. That's a line. So your job is to take these two function values and write the equation of the linear function. In other words, it's going to look like this. We use function notation, but it's going to look like that. That's a line. been given here. It says f of 2 is 3. What does that mean? When you plug in x, or 2, you get 3. Isn't this just the ordered pair, 2 comma 3? F of x, doesn't this mean plug in 2 for the x's? So if you let x be 2, y is 3. And if you let x be 4, y is 11. So you've got 2 points, and you're going to write the equation of the line. Well, shoot, you've done that a zillion times, starting when you were in 8th grade. How do you write the equation of a line? You find the slope, which for us would be 11 minus 3 over 4 minus 2, which is 8 over 2, or 4. And then what do? Pick one of your points. I'll just pick this one because the numbers are smaller. But pick one of your points. And y minus the y coordinate equals m times x minus the x coordinate. Guys, we did that in chapter P. Don't look at me like I'm crazy. Okay? So, y minus 3 equals 4x minus 8. So how about y equals 4x minus 5? Does that sound about right? I add the 3 over here. Now, since the directions specifically say write the linear function, instead of y here, I'll say f of x, just because that's what the problem says. But that's it. There's nothing new there, except you have to recognize that the given information is 2 points. All right, try the next one. It's the same thing. Different points, but try the next one. Do exactly what I just did. What'd you get for your slope? What'd you say? 1/2? Everybody get 1/2 for our slope? If you didn't, look up here at my work. 4 minus 0, 6 minus -2. Then pick a point. It doesn't make any difference which one. You're going to end up with the same answer. And then make sure, since it specifically says linear function, let's use function notation. And there it is. All right, anybody have a question about that? Easy? Okay. Number 3. Find the vertex axis of symmetry and direction of, that should say direction of opening. Sorry, I don't know what I was thinking there, direction of opening. Now wait a second. Look at this function. This is not a line. How do I know it's not a line? Squared. Oh, it's a squared, so what is it? A parabola. So we talk about the vertex of the parabola. Everybody knows what we're talking about, right? A turning point, the vertex. This is the axis of symmetry, sometimes called line of symmetry. It divides the parabola in half, right? Now, will the axis always go through the vertex? Yes. Okay. Now, your BFF, y equals x squared, has a vertex at the origin. But we have just spent a whole bunch of time talking about how to move that shape, how to change that shape. How do we move it off the origin? We add or subtract, right? So when you look at this equation, you should be able to tell me where the vertex is. Where is it? It's been moved how? Left 1 and down 4. So if the parabola has been moved left 1 and down 4, isn't that the vertex? Which way does this thing open? Now remember, the regular BFF opens up. But it opens down because what did we put in front of it? A negative. And what does a negative out in front do? Turns your picture upside down? No, you cannot be my favorite student if you're going to be on your phone. Put it away. Now, it opens down, so it looks like this. Where is the axis of symmetry? Well, it's right here, right? What is the equation of that line? X equals -1, exactly. X equals -1. Okay. We're gonna finish this up. So we've taken care, we've answered the first one, all right? So quickly, we're gonna get through B and C because they are exactly the same thing, okay? So let's look at the equation in B. Your job is to look at that equation, which, by the way, this form right here is called Vertex Form, because when the parabola is written that way, you can tell me the vertex. Where is the vertex of this? At 3, 0. Now, how did she know it was at 3, 0? This is inside the parentheses, right? So that means right. Is there a number tacked on the end? No. So we didn't go up or down. We just shifted 3 right. Up or down? Up. Axis of symmetry, x equals 3. If parabolas are in vertex form, it's as easy as it could possibly be. What does the 1/2 do to the parabola? The 1/2 multiplies the y values, multiplies the height. It has nothing to do with the location of the vertex. So in reality, this parabola is going to be skinny, or excuse me, fatter, because it's expanded out this way. But I don't care about that because right now I'm interested in where it's sitting. And the 1/2 has nothing to do with that. All right, last one. Tell me where the vertex is. -3, 10, right? Everybody okay with that? Shift left 3 and up 10. Which way is it open? Positive means up, because they quadratics open up, unless you put a negative in front of them. And this is the axis of symmetry, which is x equals -3. On Monday, or tomorrow, we'll pick up there, and we'll look at parabolas that are not in vertex form. That's where things get exciting. By the way, you know those first couple problems we did where you were writing the equation of a linear function given 2 function values? We might just do that tomorrow, just to make sure that when you all smiled and nodded at me, you really knew what you were doing.